Hello everyone. So I welcome you for yet another session on CSAT. This will be the class 3 on CSAT. As we know how we are going, we are taking a topic, we are understanding the concept behind it. Then in this next class, we are basically discussing the PYQs that has been asked on the same topic. Next, again we are moving to the new concept. Now, when I say this, there are certain topics which are important in number system, which has been, the questions has been asked in various examination, but UPSC has not asked much question on that topic. However, with respect to the unpredictability of UPSC, what we are supposed to do, we should make sure that we prepare those topics also and understanding the logic behind it. However, since no PYQ can be solved on that topic, I will take the questions that has been asked in the different examination in this session itself, and in the next class, I will move to a new concept which have a linkage from this topic, so that understanding this topic is very, very important. And also you can expect the question in future from this topic. All right. So now first we'll understand the different types of number that we are supposed to understand. The terminologies itself is important. The question will not be asked on the terminologies, but whenever in the question, if they are using the terminology, you should know the meaning of it. So just we will understand what they are. Then we will move to a different concept, that is the powers and exponents. Then we will move to a factors of number. So in the next class, in detail, we will discuss about LCM and HCF, which is again nothing but the continuation of factors, right? So that is why this base is very important to understand. So let's begin, right? So now, what are the types of numbers, right? One terminology that are called co-primes. What are the meaning of co-primes? Right, whenever you are using co, that means that we are comparing two quantities and we are talking about it. Now, when I say co-prime, what is the meaning of it? When I take any two number, right? That means that, let's say if I take, 9 and 8. Now, these two numbers are not prime. But however, what are the numbers that will divide this number? Okay. What are the numbers that will divide this number is 1 will divide 9, 9 will divide 9, 3 will divide 9. Now, if you look at 8, again 1 will divide 8, 8 will divide 8, 2 will divide 8, 2 4s are, that is 4 will divide 8. So now if I look at the factors, right, the factors means those number which divides the given number. Now if I look at the factors, between 8 and 9, apart from 1, there is no common factor. 9 has 1, 9, 3. 8 has the factors of 1, 2, 4, 8. So that means that there is no common factor apart from 1. 1 will always be common because we know that all the numbers are divisible by 1. So in that sense, any two numbers between which there is no common factor apart from 1, such two numbers are called co-prime numbers, right? So it need not to be, numbers need not to be prime, but only thing what we should understand, they should not have any common factor between them except 1. Okay. Now, if I consider two prime numbers, 2 and 5, 3 and let's say 7, they are always co-prime. Why? Because what are the factors of any prime number? That is 1 as well as the number itself. That is, if I take 2, what are the factors of 2? 1 and 2. What are the factors of 5? 1 and 5. What are the factors of 3? 1 and 3. What are the factors of 7? 1 and 7. So that means that when I take any two prime number, that is 2 and 5, only one number that is common between them, or the one factor that is common between them is 1. So any two prime numbers are always co-primes. They do not share any common factor apart from 1. That is why any two prime numbers are always co-prime. This is rule number 2. Right? What we have learned? Numbers need not be prime. Still they can be co-prime. That is one rule. Second rule, if there are two prime numbers, then they are always co-prime. Right? So that we have learned. Now the third rule, right? Now, let's say if there is one prime number, let's say 3. Now you take any other number which is not a prime number. For example, I can take 4, right? I can take 8. I can take 10. Now what is that? If I take any two number among which one is prime and the other number is not a multiple of the given prime number. That is 8 is not, 4 is not multiple of 3. 8 is not multiple of 3. 10 is not multiple of 3. So in that case, these two prime numbers are again co-primes. That is, in this case, one is prime, other is composite. However, what is the difference? The difference is the composite number is not a multiple of the given prime number. Then in that case also, both the numbers are co-primes. However, if I take two numbers, one is prime, other is composite, right? Now here what is happening? If you look at the number, first number is 3, next number is 9, right? So here what are the factors of 3? If I write 1 and 3, because it is a prime number, it will have only two factor, number and the 1 itself. Again for 1, what are the common factor? 1, 3 and 9. So that means that apart from 1, 3 is common in both the numbers. That is why when two numbers are given, among which one is prime, other is multiple of the prime number, then they are not co-prime, because there will be another common factor that exists, right? So that is why that has to be kept in mind. However, if there are two numbers, one is prime, other is composite, and this composite number is not multiple of the given prime number, then I can certainly say that these two numbers are co-prime, right? Next, let's understand one more number rule. So that means that if any two numbers or any two consecutive numbers, right? For example, any two you take 7 and 8, or let's take 15 and 16, right? Now what are the factors of 15 and 16? 1, 15, 3, 5. Similarly, what is for 16? 1, 16, then 2, 8 and 4. Now if you look at it, only common factor between them is 1. So that means that always you have to remember, if two numbers are consecutive, what is consecutive? One after the other, then those two numbers are always co-prime, right? If two consecutive numbers are always co-prime. Similarly, two consecutive odd numbers is always co-prime. For any number you take, for example, if I take 33, 35, right? If I take this will go with 1, 33, then 3 and 11. Now with 35, 1, 35, 7 and 5 and 7. Now if you look at it, what is common? 1 is common. Other than that, there is no common number, right? So that means that if there are two consecutive odd numbers are there, then they are also co-prime. However, if there are two consecutive even numbers are there, they are not co-prime. Why? Understand the logic rather than, remembering as a rule, understand the factors, right? Let's say if I take any two consecutive even number, that is one even number after the other, continuous two even numbers. Now what will happen? Since it is even, all the number will be divisible by 1. Yes, 1 is a common factor. Apart from that, since they are even, that means that what it will be divisible by? It will also divisible by 2, because it is a even number. So that means that apart from 1, 2 is also another common factor between them, because both of them are even. So in that case, two even number, whether they are consecutive, non-consecutive, if there are two even number, they can never be a co-prime number. These are the basic things that you are supposed to understand. Now why I should know this co-prime rules and all? When you are understanding LCM as well as HCF, we'll apply this concept. Again, we'll come back to co-prime, we'll understand the property of it, and then we can reduce our calculation if you know the meaning of co-prime, right? So that we will do it in the next class. Now, as of now, you understand these many features. Now, so next concept we will discuss is twin prime numbers. What are twin prime numbers? The twin prime numbers are those two prime numbers which have exactly gap of 2. If you look at it, 3 and 5, they are twin prime number. 5 and 7, they are called as twin prime number. 11 and 13, 17 and 19. Here, if you are having 13 and 17, it is not twin prime number because the gap is 4, right? Similarly, 2 and 3, the gap is only 1. So, exactly gap between these two prime numbers is 2. Such two prime numbers are called as twin prime numbers, okay? So that you should be knowing the meaning of the word. Whenever they are using that, let's say A and B are twin prime number, then you should know what is the meaning of twin prime numbers. All right. So for that, it will be beneficial. Now, next we go to the topic or the term called perfect number. What are perfect numbers? Now, perfect number are very less that is available, right? You can have 6, 28, 496 and so on and so. Now, what is this is called, let's say, if I take 6, what are the factors of 6? 1 and 6, 2 and 3, right? So that means that there are 4 factors, 1, 6, 2, 3. That means that when you add all the factors of a given number, right, except the number itself, then the sum of these 3 factors should be equal to the given number. That means that if you take 6, what are the factors? 1, 2, 3, 6, right? These are the factors. Factors means number that is dividing the given number, that is 6. Right. Now, if you add all the factor apart from the number itself means if without 6, if you add remaining factor, that is 1 plus 2 plus 3. 1 plus 2 is 3, 3 plus 3 is 6. Now, which is equal to the number itself. That number is called as perfect number. Now, let's look at another number which is 28. Right? If I take 28, what are the factors? 1, 28 is 2, right? And then 14 is then 4, 7 is. Now, apart from 28, I will leave out this 28, that is number itself. If I add all the remaining factor, how much I will get the sum? 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 7 is 14, 14 plus 14 is 28. Such numbers, that is if you add all the factor apart from the given number, if you add all the remaining factor, the sum is equal to the number itself. Such numbers are called as perfect number. So if the question is giving x is a perfect number, then you should knowing that apart from the the number itself, remaining factor if you add, right, then you will be getting the answer as the number itself, that number that they are talking about. Or if I am adding that factor also, then the number will be double the given number. That means that 1 plus 2 plus 3, 6 plus 6, another factor also if I add, answer will be 12, which is twice the given number. Similarly, here if I add, this many will give me 28 plus this 28 make it total 56. That is, the sum of all the factor is twice the given number, including the number itself. If I add, answer will be twice the given number. In whatever the way you want to define, you can define it. So this is called as perfect number, right? Now, the next is called triangular number. What is the meaning of it? Let's say 1, right? This is a series, triangular number series. What is this? The first number is 1, right? Next number is sum of the first 2 natural number. What is first 2 natural number? 1 plus 2. What is 1 plus 2? 3. Now, the third number in this series will be sum of first 3 natural number. 1 plus 2 plus 3. How much is 1 plus 2? 3. 3 plus 3, 6. That is the third number. What is the fourth number? 10. That means that 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 is 6 plus 4. That is 10. So these numbers are called triangular number. What will be next number? 10 plus 5, 15. What will be next number? 15 plus 6, 21. Like that, if you add first, natural numbers, that will be giving you the number. So in that series. So second term is sum of 2 natural number. Third number is sum of 3 natural number. This series we call it as triangular number. That is what you are supposed to understand, right? Now, before going to the exponents, you'll also understand a basic rule. How to find a given number is a prime number or not, right? So if, for example, if I give you, let's say 17, I ask you whether it is a prime number or not. Now, what will you do? You have to check whether it will be divisible by, 1, though it will always be divisible, you don't need to check. 17, though it will always be divisible, you don't need to check. Apart from that, all the number I have to check. So whether I have to see whether it is divisible by 2, it will not be divisible by 2. If it is divisible by 3, no. Again, it is divisible by 4, 5, so and so, right? Now, if the number is larger, I cannot keep doing it. For example, 31 is there. Then I cannot keep doing it for 1, then 2, then 3, 4. Because 1 anyways it will be divisible. Apart from 1, if I start doing, that will become a lengthy calculation. So, to understand how to find a given number is a prime or not, first we understand the basic rule by writing the factors of any given number, how it will work, right? And then apply the same logic then for the prime numbers. First we'll take a composite number, right? Let's take, a simple number 6. Then I'll take another number 10. Another number, let's say, I will take is 20. And another number, finally, 16. Let's take 4 numbers to understand. What is 10? What are the various factors of 10? If I write 1 tens are 10. Next, whether it is divisible by 2? Yes. 2 fives are 10. 3, it will not be divisible. 4, it will not be divisible. 5, again 5 twos are 10. 6, 7, 8, 9, it will not be divisible. 10 ones are 10. So when I take 1, I am already taking its pair together. When I take 2, I am taking its pair together. So if I check with 2, then you don't need to check with 5. If I check with 1, you don't need to check with 10. Right? So these are the 4 factors. Now let's look at 6. 1 6 2 3 Then if I want to check with 3, I have already checked because 2 into 3 is nothing but 3 into 2. So 1 into 6, 2 into 3. These are the 4 factors. Now again, if I go for, let's say, 16, then 1, 16, 2, 8 3, it will not be divisible, 4 4s right? So 4 4s Again, 5, it will not be divisible, 6, it will not be divisible, 7, it will not be divisible, but 8, it will be divisible, but I have already taken that 8 with 2. Similarly, I have taken 16 into 1. These are the factors that will be divisible. Similarly, if I look at 20, 1, 20, 2 tens 3, it will not be divisible, 4 fives Then 5, I have already taken with 4. So again, I don't need to check 5, 4. So now if you look closely, what is happening, right? Now observe this. This is very, very important. 1, if I divide the factors, always if a number is not a square number, it will always have even number of factors. Now you can see this. Total, how many factors are there? 4 factors are there. This is not a square number, perfect square. How many factors are there? 4. Because always they come in pair, right? So if you are taking 1, you are already taking 16 also. They come in pair. So that will be always even. If I take 20, which is again not a perfect square, so that means the total number of factors are 6. Alright. So but when I take a perfect square, that is 16, let's take 9 also. 1, 9, 3 3s Now how many factors are there? If you look at 1, 2, 3, 4, 4 cannot be counted twice. I will count it 1 only. So that means the total factors are 5. Here, the total factors are 1, 3 and 9, that is 3. So that means that whenever a number is a perfect square, total number of factors will always be odd. Similarly, whenever a number is not a perfect square, then total number of factors will be even. This is the basic rule, 1. Now again, another rule if you closely observe, right? Half of the factors, right? If you look at here, 16 if I take, half of the factor, that is 1, 2, 4. Others are 4, 8, 6. This side, I can take all the factors that are equal to or less than square root of the given number. Remaining factors are more than the square root of a given number. For example, if I take 6, 2 square is 4, 3 square is 9. So that means that square root of 6 will be between 2 and 3. So I can say that, the half of its factor are less than, 3. And half of the factor will be 3 are equal to more than 3. That means that if I take 6, how many factors are there? 1 and 2, which are less than 3. And then 3 and 6, which are greater than or equal to 3. Similarly, if I take 10, 10 square root of 10 is what? It will be 3 square is 9, 4 square is 16. So it will be between 3 and 4. So if I keep checking, the 2 factors 1 and 2 are less than 3. Similarly, remaining 2 numbers, that is 5 and 10, are more than 3. Similarly, for 20, what is the square root of 20? It will be between 4 and 5 because 4 square is 16, 5 square is 25. So square root of 20 will be between 4 and 5. Half of the factor are less than 5 and remaining half of the factor are greater than or equal to 5. So that means that you don't need to check all the number. Only up to square root you check. Remaining anyways comes in pair. So you don't need to check that. So that is the basic rule. Now, the second part is what? Let's say if a number is 20, right? Now, let's say I checked with 1 and 20. Second number I am checking is 2 and 10, 4 and 5, right? If a number is, divisible or not divisible by 2, for example, it is a number is not divisible by 2, then it will never be divisible by any multiple of 2 also. For example, if I take 9, right? So if it is 9, 1, 9, 3 square, right? If it is not divisible by 2, that means that it will not divisible by 4 also. It will be not divisible by 6 also. It will not divisible by 8 also. Because all these numbers, I have 2 within them. 4 is nothing but 2 into 2. 6 is nothing but 2 into 3. If it is not divisible by 2, then it will not be divisible by the multiple of 2 also. So if I check 2, then you don't need to check 4. You don't need to check 6. You don't need to check 8. Similarly, if a number is, let's say, take this number. This number is, it is not divisible by 3. If it is not divisible by 3, then it will not be divisible by any multiple of 3. That means that it will not be divisible by 6 also. It will not be divisible by 9 also. It will not be divisible by 12 also, 18 also, 15 also. That means that any multiple of 3 will also not dividing it because it is having 3 within them. So that means that what I am to check? I check only those prime factors. No need to check all the numbers. So that means that when 17, they are telling you to check whether 17 is a prime number or not. They are telling you to check when 31 is a prime number or not. When I am telling you to check whether 39 is a prime number or not. Now let's understand one by one. 17. First rule is what? I need to check only up to square root. What is square root of 17? It will be between 4 and 5. Right? Because 16 is 4 square. 25 is square. That means that 70, square root of 17 will be between 4 and 5. So all I need to check is up to 5 only. That is rule number 1. Second, as you already know, you don't need to check with all the number. Only check with the prime number. Because if it is not divisible by 2, it will never be divisible by 4. It will never be divisible by 6. It will never be divisible by 8. So, right? So, all I have to check is 2 first. 2, it is not divisible. Right? Next prime number I need to check. That is 3. Again, it is 17 is not divisible by 3. Do I need to check 4? No. Why? Because 4 is nothing but multiple of 2. If you check prime number, that's it. You don't need to check the number which is not a prime number. Next prime number will be 5. Again, 17 will not be divisible by 5. So, I can say that, again, should I check 6, 7? No. Because what we are supposed to check? Up to square root of a number. That's it. That means that we have to check with 2, we have to check with 3, we have to check with 5. So, 2 rules. 1, up to square root. And with which number you are supposed to check? Only the prime number less than equal to the square root of the number. So that means that I check with 2, I check with 3, I check with 5, I say that 17 is not a prime. Similarly, 31. 31, if you take square root, it is 5 square is 25, 6 square is 36. So it will be between 5 and 6. So check up to 5 or 6. All the prime numbers less than 6 if you have to check. So check with 2. Whether 2 is divisible by, 31 is divisible by 2? No. Check with 3, another prime number. Whether 31 will be divisible by 3? No. Similarly, next prime number below less than 6 will be 5. So, is 31 be divisible by 5? Yes. No. So, that means that it is neither divisible by 2, 3 or 5. So, that means that 31 is not divisible by any of the factors. So, that means that 31 is a prime number. You don't need to check 6, 7, 8 because it is more than a square root of a number. So, next number, let's say 39. When I want to check 39, so what I have to check? 39 is, square root of 39 is what? 6 square is 36, 7 square is 49. So, between then you are getting 6 point something, you take the next number. That is, between 6 to 7, I take up to 7. So, all up to 7 only you have to check. And up to 11, what numbers you are supposed to check? Only prime number. That is 2, 3, 5, 7. Whether 39 is divisible by 2? No, because it is an odd number, it will not be divisible by 3. Now if you check with 3, 3 ones are 3, 3 threes are 9. So it will be divisible by 3. 3 and 13. 3 13s are 39. So that means that 39 is not a prime number. You have already got your number. Right? Similarly, if I take the last number, let's say, something like 63. Okay. So if I take 63, what is this 63 is about? Now, if you know that the square root of 63, right? 7 square is 49. 8 square is 64. So 63 is less than 8. So up to 8 you are supposed to check. But what you are supposed to check? Only the prime numbers. That is 2, 3, 5, 7. Okay. So that means that if I check with 2, it will not be divisible. If I check with 3, right? 3 2s are 3 1s are. It is divisible by 3. Similarly, 5 it is not divisible. 7 9s are 63. It is divisible. So that means that the number is divisible already by what? 3. So that means that 63 is not prime number. 63 can be written as 3 into 21 also, 7 into 9 also. So in this way, only up to this number, only the prime factors if you check, you will come to know whether the number is a prime number or not a prime number. Right. So that is how you find the factors. Once you find the factor, the opposite or the pair of the factor you will get automatically. That is how you are supposed to understand. Now that is with the types of the number, how to find whether a number is a prime or not. Then with respect to co-prime numbers and their properties we have learnt in detail. Now we will move to the powers or the exponents. Now here what I will do, there different properties are there. Rather than mugging up the properties, I don't believe in mugging up it. So always I understand the logic behind it rather than mugging up it, so that whenever the question comes, we just don't need to remember and then apply it. Right? We should just understand the logic behind it. First, understand what are the powers. Powers are what? For example, if I write 2 to the power 4, 3 to the power 5, 4 to the power 3. So what is the meaning of it? It is nothing but it is a shorthand form. Because what is 2 to the power of 4 is nothing but 2 into 2 into 2 into 2. I am multiplying 2 with itself. How many times? 4 times. What is 3 to the power of 5? 3 into 3 into 3 into 3 into 3. That is, I am multiplying 3 with itself. How many times? 5 times. So it will consume lot of space. So what I will do? As a shortcut, I will write 3 to the power of 5. So it is nothing but whenever you are having 2 to the power of 10, it is nothing but 2 has been multiplied with itself. How many times? 10 times. Similarly, what is 4 cube? 4 into 4 into 4. This is the power. Meaning of power is nothing but only this. Now, once you understand this, let's go to the properties. Here what I will do for our understanding, I'll consider base. Here when I am telling about 2 to the power of 5, I am raising 2 how many times? Or multiplying 2 how many times? 5 times. So the base is which number you are multiplying with itself. That is called as base. Right? So that is 2 is a base here. And this is called as exponent or power. Okay, these two terminology you should be understanding. Now, what is 0 exponent? That is anything power 0, 2 power 0, 3 power 0, 4 power 0. What is the meaning of it? It is basically equal to 1. Any power 0 will be equal to 1 except 0 to the power of 0. So this is always, questionable whether 0 to 0 should be 1 or not. Sometimes we take it 1 or not 1 based on the, where we are applying it. But for our understanding, apart from 0 base, any base whose power 0, answer will be 1. Right? Now let's understand. We'll come to negative power later. First we'll understand what is the meaning of product of powers. Right? What is the product of power? Let's say if I take 2 cube into 2 square, what should be the answer? Right? So what is the meaning of it? First you think the meaning of it. What is 2 cube? It is a simplified version of 2 into 2 into 2, shorthand version. What is 2 square? Again 2 into 2. So how many times 2 I have multiplied with itself? 5 times. 2 to the power 5. Similarly, let's say 3 to the power of 4 into 3 cube. What I am doing? I am expanding it 3 into 3 into 3 4 times. Also, I am continuing this. 3 cube can be written as 3 into 3 into 3 3 times. How many times 3 I am doing that? This is 4 times. This is 3 times. Total how many times? 7 times. So I can write 3 to the power 7. So I'm just expanding and writing, right? So that means that you should not say 3 to the power 2 to the power of 3 into 2 to the power of 2 is 2 to the power of 6. You should not write that. Why? Here 2 has been expanded 3 times and again 2 has expanded 2 times. Total how many times? 5 times. So all I have to do is add these two. This is 3 times, this is 2 times, total 5 times. So that means that if a number is base is a, it is having power m. Similarly, another number with the same base a, but it is having power n. Then a has been multiplied m times. Again continued another n times. Total how many times? A to the power m plus n. So similarly, 3 to the power of 4, 3 to the power of 3. You should not write it is 3 to the power of 12. What you should understand? 4 times 3, 3 times 3. Total how many times 3? 7 times. So keeping the same base, that is 3 as it is, I will add the powers, that is 4 plus 3, 7. So it will be written as 3 to the power 7. Right? Similarly, quotient of powers. What is quotient of powers? Let's understand quotient of powers. Okay. What is quotient of power? Let me write it this way. Right? 3 to the power of 5 divided by 3 square. What is the meaning of it if I write like this? 3 I am multiplying 5 times, dividing it by 3 square, that is 3 has been multiplied 2 times. This will get cancelled. I will get with 3. Right. Similarly, that is 3 has been how many multiplied? I will remain with 3 times. Similarly, if I am having 2 to the power of 4, right, or let's say 2 to the power of 4 divided by 2. 2 is nothing but, if I not written any power, it is power 1 is always the same number itself. So 2 into 2 into 2 into 2 divided by 2 1 times, that is 2. 1 2 1 2 will get cancelled, 2 cube. You should not say again 2 to the power of 4 by 2 to the power of 1. I'll keep the same base, then divide 4 by 1 keeping answer as 4. No. What you are supposed to do, this has been expanded 5 times, this has been expanded 2 times. However it is, will get cancelled, remaining that what you want. That means that if here it is 5, here it is 2, 2 3s will get cancelled, remaining 3 will be there. That means that whenever I am writing, now I can directly write if 3 is common base, from the higher power you are subtracting the lower power. That is from the numerator power you are subtracting the denominator power. That is 5 minus 2. 5 minus 2 is how much? 3. Similarly here 2 you are keeping as it is. You are subtracting the power of the numerator and the power of the denominator. That is 4 minus 1. How much? 2 cube. So that is why if there are two numbers, right, which is saying a to the power m divided by a to the power of n, how I should write? A to the power m minus 1. How much extra is there? Remaining will get cancelled. How much extra I will be left with? That you are supposed to see. Right? That is about your quotient of power. Now similarly, power of a power. What is power of a power? Let's understand power of a power. Now let's say you are having 3 square whole square. Right? So what is the meaning of it? First I will say whole square is there. That is, first I will take 3 square as a base. How many times I have to multiply? 3 square, 3 square. Because the 3 square has been multiplied how many times? 2 times. Now 3 square can be further written as 3 into 3 into 3 into 3. Right? So that means the total 3 to the power 4. Similarly, let's say I have 2 cube whole square. So what is the meaning of it? If I am writing 2 cube, how many times I have to expand? It is square, so I am expanding 2 cube, 2 cube. Now this 2 cube can be written as 2 into 2 into 2. Again, this 2 cube can be written as 2 into 2 into 2. So total it will be 2 to the power 6. So what I directly can do, same base, keeping as it is, power of a power, I multiply these two. 2 into 2. That means that 2 into 2 is 4. Keeping the 3 as it is, 2 into 2 is 4. Similarly, here 2 is the common base. Keep the 2 as it is, you multiplied 3 into 2. That will be 6. So directly write it as 2 to the power 6. Right? Here you are supposed to multiply. You should not add. Adding is when two numbers are, if it is 2 cube into 2 square, that is very different from 2 cube whole square. This difference you should understand. 2 cube into 2 square is 2 is written 3 times, 2 is written 2 times, total 5 times. Here 2 cube is written 2 times, that is 2 cube into 2 cube. Each 2 cube is 3 times 2, 3 times 2. So total 6 times. So whenever if I want to write a to the power of m whole to the power n, that is nothing but a to the power m into n. This is another rule, right? So rather than working on, understand the logic behind it, how it has been written. So a into m to the power of n, this is also same, or a to the power of n into same, this is also a into m into n, or n into m, both are same. What is the meaning of it? If you just understand again, what is the meaning of it? If I write 2 cube square, this means that 2 cube into 2 cube, 2 into 2 into 2 into 2 into 2 into 2. So that is basically 2 to the power how many times? 6 times. This is also same. If I write 2 square whole cube, here what is happening? 2 square has to be expanded how many times? 3 times. 2 square into 2 square into 2 square. Right? Each square is nothing but 2 into 2, 2 into 2, 2 into 2. So that means that how many times 2? 2 to the power 6. That is why a to the power of mn is also same. A to the power of n whole to the power of m is also same. So that is basically the power of a power. This we have covered. Now, power of a product, right? So what is power of a product? Right? What is power of a product? We'll go to another example, right? That is, if there are 6 cube. Now, this 6 can be written as 2 into 3. This is a power 2 into 3 whole cube, right? That means that it is 2 cube. That is what is 2. So, see, understand the logic. 2 into 3 whole cube. How I can write in it? 2 into 3. Again into 2 into 3. Right? Again into 2 into 3. Because 2 into 3, how many times? 6 has to be multiplied 3 times. That means that 2 into 2, 2 into 2, 2 cube. Similarly, 3 into 3 into 3, that will be 3 cube. Right? So that means that, this is 8. This is basically 3 cube is 27. This will be your answer. That means that if there is, a into b, there are two numbers which are having the same power m, then I can write it as a to the power of m into b to the power m. This is another rule. Now, right? So now, what is negative exponents? Negative exponent is nothing but if I write something as 2 to the power minus 2, what is the meaning of it? It is nothing but 1 by 2 square. If 2 to the power of minus 3, 1 by 2 cube. This is you are supposed to understand. Right? Similarly, the last one we are having is power of a quotient. The fractional exponent I will explain you when I am explaining you the other concept. Right? So now we will keep it a power of a quotient. What is power of a quotient? Similarly, how two numbers were there, right? For example, I have, let's take like this. It has been written as, let's say, 4 by 2 whole cube, right? So now if I am writing it, I can write 4 cube. What is 4 by 2 whole cube? First we will bracket, we will do 4 by 2 is 2. 2 is nothing but what? 2 cube is nothing but 8. Answer is 8. I can write this like this also. 4 cube divided by 2 cube. Both 4 cube also, 2 cube also. What is 4 cube? 4 cube is 64. What is 2 cube? 2 cube is 8. 64 by 8. 8 is a 64. So answer will be same. So a by b whole to the power of m is equal to a to the power of m divided by b to the power of m. Like this I can write. This much you are supposed to understand. Okay, this is a basic. Direct question has not been asked, but property, if you know whenever the exponents have been, then you can understand. Now let's solve 2-3 questions to make how the question can come in the CAT examination, GMAT examination, because now UPSC is getting inspired by this examination. So we have to make sure that we are ready with those kind of questions. Not that only the topics that has been appeared I will prepare. Right? Now, first question. How many digits does the number 2 to the power of 40 into 5 to the power of 30 have? Question number 1. First, let's solve this. Okay. That is, what is the question? How many digits you are having for 2 to the power of 40 into 5 to the power 30? Think about it. How you can solve it? How many digits are there in this sum? Who knows, sir? How I will be knowing it, sir? So to understand this, let's understand the logic behind it. What I can write? let's say if there are a number, right? So if you observe here, what we had done, whenever a number is having 2 power, if the product is having same power, then I can directly multiply it, right? So what I will do, I will write 2 to the power of 10 as 2 to the power of 10. That is, what is 2 to the power of 40? 2 has written 40 times. First I will write 2 to the power of 10 and 2 to the power of 30. That is 10 plus 30 will be 40. Similarly, into 5 to the power 30. Now what I have done? Either you try to make the base same or you try to make the power same. Here what I have done? I have done 2 to the power of 30 also, 5 to the power of 30 also. Now you in the formula we have known a to the power b whole power m will be how much? A to the power of m, b to the power of m. Here the power is same, right? So what I have made? I have made the power same. That is 2 to the power of 30. Here 2 is nothing but this, 5 is nothing but this. So 2 to the power of 30, 5 to the power of 30 is nothing but 2 into 5 whole to the power of 30, because a into b whole to the power of m can be written as a to the power of m, b to the power of m. Here already I have made it in a to the power of m, b to the power of m. That means that I can write 2 to the power of 30 into 5 to the power of 30. What I can write? 2 into 5 whole to the power of 30. And this 2 to the power of 10 I will keep as it is. Now what will happen? 2 into 5 is how much? 10. 10 to the power of 30. Right? If you multiply 10 with any number, 1 0 you will get. If you are multiplying any number at 10 square, that is 100, you get extra 2 zeros for your answer. Let's say if I am multiplying 3 into 10 square. So 3 I will keep it as it is, and 10 square will give me 2 zeros. It will become 300. If I have 21 into 10 square, 10 square will give you 100 into 21. That means that I will get 2100. That means that whatever the number followed by that many zeros, how many 10 power is there, right? So similarly here 10 to the power of 30 is there. That means that how many zeros you will get? You will get 30 zeros, and 2 to the power of what? 2 to the power 10. So what is 2 to the power of 10? 2 to the power of 10 is nothing but 1024. So answer will become 1024 into 2 to the power 10 to the power 30. So when it is 10 to the power of 30, this will give you 30 zeros. 1024 followed by how many zeros? 30 zeros. So that is this 4 number plus 30 zeros. Total number of digits will have become 34. That is 30 zeros plus 1024. That is number. So 4 plus 30. Final answer will be 34 zeros. This is a kind of question you can expect. Only by, so what is your job in the exam? Always make sure either you have to make the same base. That is, either make it 2 to the power of 5 and 2 to the power of 8. Then also you can just add 5 plus 8. Or you can make the power same and keep the base different. Because if the power is same, that is 2 cube into 3 to the power of 3 cube, then what you can do? Since the base are different but power are same, what I can do? I can say it is nothing but 2 into 3 whole cube, right? So either try to make your base same or try to make your power same. Then you can apply this formula and get the answer. So answer would be 34, right? Second question. If x is a non-zero number such that first number is what? Non-zero. It cannot be 0, right? Because any power of 0 will always be 0. 0 square is also 0. 0 cube is also 0. Right? So, they have told that x is a non-zero number such that x to the power of 4 is equal to x to the power 6. What is the sum of all possible values of x? Right? So, a different value of x is there. If you add all of them, what will be your answer? Now, how do I do it? Let's understand. Now, they have given x to the power of 6. These are equal. So, if I cross multiply x to the power of 6 divided by x to the power of 4, which is nothing but 1, right? So, if I do cross multiplication. Now, you tell me what is x to the power of 6 divided by x to the power of 4? A to the power of m divided by a to the power m. That is same base is there, different power. If you are dividing it, what it will be? A to the power m minus n. That is the difference between, because x has been multiplied 6 times. divided by x has been multiplied 4 times. 4 times 4 times will get cancelled. How many x extra you will left with? 2x. That is, this answer will be x square. X square is equal to what? 1. If x square is 1, know what will be the value of x? What are the value of x? Square root of 1 can be 1 also, or x can be minus 1 also, because minus 1 into minus 1 will be plus 1. Plus 1 into plus 1, plus 1. So that means that either value of x will be 1 or value of x will be minus 1. There are two different values I am getting. What is the question? All possible values, sum I want. That is, I wish to add plus 1 with another value of x, that is minus 1. 1 minus 1 will be how much? 0. So the answer is 0. This is another kind of question. Right? So here what we have done? We have given x to the power of 4 equal to x to the power of where? X is the common base. So you can use the same rule and get the answer. Those are the two questions that I have made you to solve. Now, I will give you two practice questions. Okay? It is your job to solve this, using the logic. Right? How it would have been, and then try to answer such questions. Okay? A UPSC has asked similar type of question, but not with the same logic, but a similar type of question. So what is this question? Which of the following number is the largest? They have given 2 to the power of 500, 3 to the power of 400, 4 to the power 300, 5 to the power 200. 5 numbers have been given. Okay? Now it is your job to solve this question. Which is the largest number? Think. Whenever you are trying, a hint I will just tell you to thought process. Either in the exponent problem, what you are supposed to do? Two things. One, make the base same if it is possible. If it is not possible, then what you are supposed to do? Make the power same and compare. Okay? So in whatever the way you want to compare, you can do that. Okay? So keep these two things in mind and try to put the answer with the logic you have applied. That is question number 1. Which among the following is the largest number? Next. Next question. If 2x plus 2x plus 1 plus 2x plus 2, that is, 2 to the power of x, 2 to the power of x plus 1, 2 to the power x plus 2 is equal to 112, what is the value of x? Okay, first try to solve through the logic. If you don't get, then try to go through the options and try to solve it. Whatever the way you do, you try to do it. Right? First, always think the logic, how it can be solved. Okay? With that, basically, I will explain the answer when I am doing in the next video, that you can go through them. But your comments, if you are not getting too many comments, that means that you are not participating. That will not, motivate me to do further, because, the entire CSAT, if it has to be done, it takes lot of energy from my side. Lot of problem has to be brought, simplifying the concept, everything I have to look into. More you participate, more you like, more you comment, again, as I have told you in the previous video, I don't know, thank you sir, it was very enriching, that kind of comment. I want your participation. If you're liking it, that is a kind of participation. You are showing that you are liking. You are, understanding the thing. Or if you are commenting, then you are knowing that you are solving and trying to solve it. In that way, try to, come up with your answer. So that is what it is, the powers. With respect to the fractions of a power, that we will going to discuss when we are discussing the other topic where it is necessary. Right? So let me keep it today. First classes is the basic classes that you understand the logic behind them. Right?